Hello everyone, today we are going to be discussing the importance of using decision matrices when deciding on designs for your robot. Let's start by explaining what a decision matrix is. A decision matrix is a tool that is used to allow teams to make design decisions together by weighing the pros and cons of each considered design. It is used to decide from the different options listed for the subsystems of your robot. On the screen is a photo of a decision matrix. As you can see, a tank drive type with 3.25-inch Omni wheels was chosen due to how it received the most total points in the end. The categories selected for the decision matrix are different based on things you are designing. For example, if your team wanted to decide on a lift, you should make a decision matrix with categories such as height, weight, practicality, speed, structural integrity, strength, and other things necessary regarding the reasons you are building the lift. Let's say you need to build a lift to an extremely tall platform. Then you might want to consider including height as one of your categories. These categories may change from year to year depending on what you have decided you want your robot to do. A team will unanimously decide on point values for each of the categories that were used. Each category's point value will be determined based on how important it is to the team. For example, space might be worth more points than defensive capability, so space will be ranked out of 12 as opposed to defensive capability, which will be ranked as a 6. To rate each category for each design, every member will list out their scores for every design, and then the team will add each corresponding point value together and take the average. The average will be put into the final decision matrix. For example, if I were ranking lift designs, and Scott ranked the 6 bar as an 8 for weight, but I put a 6 for it, then we would put 7 into the final score for that box since that is the average. This would be done for each design in every category. Add up the total score for each design after the averages are taken. The one with the highest total score is the winner. This is the design that your team will go with, assuming it is in line with your team's consensus. When you are making your decision matrix, you might be tempted to only do 2 or 3 different designs. However, it is best to consider all of the developed ideas that came from your brainstorming and research. This way, you can make a non-biased selection for a subsystem while considering all of the thoughts from the team. If one of the lifts is favored and the team thinks it will be the best, then it should be able to prove itself as the superior option. However, if this is not the case, the decision matrix will show you that you are blindsiding another good option solely because you liked one over the other. Underneath the decision matrix, you will want to include paragraph explanations for exactly why you chose the categories that you did. Explain why you ranked the categories the way you did with their weighted points, and why each category is important for this subsystem. Here, you will want to write a paragraph on why the decision matrix ended up the way that it did. Explain specifically why the winning design outranked the others, and why it is good for your robot. It is important to note that your team can overrule the decision made from the decision matrix if everyone agrees. And there is a good line of reasoning why, besides just liking the other one more. In the same paragraph, it is also important to list out the reasons why this design was picked over the other designs. This may seem like a repeat of the previous slide, however, it is not. Here, you go into the specifics of the other designs and show their weaknesses in comparison to the design chosen. Do not overlook the other designs' strengths in this area. List it all out and explain why your design is chosen despite the pros of all of the other designs. Thank you for watching our video on decision matrices and their importance in VEX.